In this chapter, we're going to be studying linear relations. In this lesson, we're going to look at slope and direct linear relations.
Okay, hi everybody. So in this chapter we're taking a look at linear relations. And we're going to start off by looking at slope and direct linear relations. Now you should have seen the word slope before. I mean it shows up not only in math classes but in science classes as well. And what slope is it's really like a measure of the steepness of a line. Now in this little paragraph here I also mentioned that really, if you want to think about it, it's almost like it's a measure of the angle that a line makes with the horizontal. So here's your line right here, then here's the horizontal. In some ways it's sort of like that, although it's not directly that. Like slope isn't this angle, but it's really closely related to that angle. But it's the ratio of how much a line changes vertically over a change horizontally, right? So it's the amount that this thing changes up and down from this point to, let's say, this point, compared to the amount that it changes horizontally. And that ratio communicates something to us, right? And you probably have heard it stated as rise over run. Okay, or you might see it as the delta y over the delta x. And remember the delta, remember that this right here means change in. So change in y divided by the change in x. Now you might also think about that as the way, or how much the independent variable changes, okay, which is the x here. The x is the independent variable. How much a change in that causes a change in the dependent variable, okay? Because the dependent variable depends on the value of the independent variable, okay? Now, one of the things that actually I should mention at this point here is when we're taking a look at the coordinate plane on the graph here, what I find is a lot of times the mistake that people make with this is they forget that x goes this way and y goes this way. And when I give you a point on a graph here, when I give you its coordinates, I'm going to give you the coordinates. I'm going to give you the x coordinate first and then the y coordinate second. More often than not, and it happens a lot here, people will flop those two. And they'll do the y coordinate first and then the x coordinate. They won't even really be aware that they're doing it. What people tend to do, though, is they tend to start at the origin, then they look up and down first and then left and right. And really what you should be doing is going left and right first and then up and down. Okay? It's like I ask, do you understand the coordinate plane? And then you answer no. Think about it for a little bit. Yes. Okay? So you shake your head, no, to get out to the x coordinate, and then yes, look vertically to get the y coordinate. So to come up with the slope of a line segment, you need 2 points. Okay, and so when we're going to typically label that, we'll start with point A, and then we'll call it x1, y1. So we're going to do a little subscript here. Anytime you see subscripts in math, they're almost always being used just to help label something. Okay, so x1, y1, that's the first point. B is point x2, y2, and then again, the 2's there tell me that this is the second point here. And so your slope, and we use the letter m to represent the slope, is going to be the change in y divided by the change in x. Now that means the difference between the, sorry, that should have been y2 minus y1 divided by x2 minus x1. Okay? So the second y coordinate, and then we subtract from that the first y coordinate, divide that by the second x coordinate, subtract from that the first x coordinate. Please make sure that you're putting the y coordinates up here and the x coordinates down here, and please make sure this right here, this little column, this is point B, this column right here is point A. Now, just a couple things before we get into this, just some things to note here, that if the slope is constant, if you've got a graph, something that you've drawn there, if the slope stays constant all the way along, so it doesn't matter what 2 points you pick, you always get the same slope calculation, then you're looking at a straight line. That's one of the properties of a straight line, and you call it a linear relation because it has a constant slope. It's the same slope all the time here. Now, if the slope changes, and I'll just give you an example. So here, right here, that line right there, the slope is always the same. No matter what 2 points you pick on it, it's always the same. But if you got something that's doing this, well, the slope between those two lines, those 2 points, and the slope between those 2 points, well, that's a different slope. As soon as the slopes start to change, it's non-linear, okay? And then one more thing we wanted to mention before we get into a couple questions here is what a direct linear relation means. A direct linear relation, all it means all it means is that we've got this linear relation, so it's a straight line, but it goes through the origin. It passes through the point 0, 0. The reason why that's significant is because if I know that it's a linear relation, if it's a straight line and I know it's going through the origin, then I know that it's going to have an equation that's simply going to be y equals m times x, or the slope times x. I need the x and the y to be there because it's not an equation of a line if I don't have the two variables there. So x being the value that I pick, y being the value that results from that. But then the slope stays constant all the way through. And that's the slope. This right here is the equation of a direct linear relation. Okay, let's take a look at this question right here. It says, suppose a line has a rise of 18 and a run of 24. What's the slope of the line? Okay, well, we know that slope is rise divided by run. It's this ratio here. So if it's got a rise of 18 and a run of 24, I mean, that's what they're telling us. But we typically, we're all pretty lazy here, so we want this to be as simple as possible for us to work with. 18 and 24 are both multiples of 6. Okay, 18 is 6 times 3, 24 is 6 times 4. So because I can do the division here, even before I do the multiplication at the top and the bottom, I can cancel those 6's. And I'm left with 3 divided by 4. So that's the slope that I'm interested in. Now, I can use that because, look at the next question here. It says, using the same line, and as soon as I say using the same line, what I mean is the slope stays the same. It's this constant slope here. If we measure a run of 60 units between 2 points, what would the corresponding rise be? Well, again, I know that the slope is rise over run. Okay, rise over run. In this particular case here, I know that that's supposed to be 3 over 4. But in this case, I also know if I've got a run of 60 here, okay, that I can put that at the bottom, okay, and it says what would the corresponding rise be? Well, let's put a variable here. Let's call that, I don't want to call it x because I don't want to get confused with like kind of the vertical and the horizontal here. We'll tell you what, let's call this y. We'll put the y there in the numerator. And so now what I'm going to do is I've got this ratio here, and I solve ratios by doing cross multiplication and then division here. So 3 times 60, or 180, is going to equal 4 times y. And then what I'm going to do is I'm going to divide 180 by 4, right, to get the y by itself. And when you do that, you can just think about how angles work, and that might even help you here, because it's the same kind of numbers here. Well, it turns out that that's 45. So this line here, that has a slope of 3/4, if the run is 60, then the rise would be 45. Okay, now the next part of this question says using the same line, which again means the same slope. If we measured a rise of 75 units, what would be the corresponding run? Well, if you are using cross multiplication here, then it doesn't really matter whether I give you the rise or the run. Your work is basically the same. But in this case right here, the rise is 75, so I put that in the numerator. The run is usually associated with the x coordinate, so I'll put an x down there. But we do the same thing. Okay, so it's going to be 3 times x will equal 4 times 75. Okay, just want to make sure I get this. I think I know off the top of my head. Yeah, and I was right. Yeah, 300. And so now when I divide, x is going to equal 100. So there's my corresponding run. But whether I give you the rise or the run, okay, and ask you to find what's missing here, you'll just cross multiply and then divide by the coefficient of the unknown, the variable. Okay, so now for this question here, don't get thrown off by the way they've represented this here. Now, this is supposed to say slope. Suppose that a line has a slope of 0.85. So they're giving it to us as a decimal now instead of a fraction. That's not uncommon. In fact, sometimes you're going to see slope given as a percentage, in which case, for example, this might have been a slope of 85%. And then you would know to convert that to 0.85. And then there, that 0.85 becomes, if you convert that into a fraction, 85 over 100. And so there's your rise and your run there. So like a good example of that is you might see that sort of thing when you're driving along a highway or whatever, and you hit a kind of a steep hill. Sometimes they'll give you the grade as a percentage, and that's basically what they're doing here. Now, using the same line, so constant slope, same line. If we measured a run of 17 units between 2 points, what would the corresponding rise be? Well, once again, we're going to use this slope here And now I'm going to use it as the 85 over 100. Measured a run of 17 units, so I know that that's down here. And again, I don't know what the rise should be. I'm going to use y for the rise here. But I cross multiply, so I'm going to get 85 multiplied by 17 should equal y multiplied by 100. Now let's figure out what 85 by 17 is. That's going to be 1445, so 1445 is equal to y multiplied by 100. And now I'm just going to divide by 100. And that's actually, it's pretty easy because I'm just going to move the decimal 2 over then. So this becomes 14.45 is equal to y. And that makes sense. That makes sense. When you look at your slope here, the rise is a little bit less than your run. So I would expect with a run of 17 that my rise would be a little bit less than that. If we use the same line and we measure a rise of 5 units, what would we expect the corresponding run to be? Well, let's set up the ratio again. 85 over 100 is going to equal, now my rise is 5, so I'm going to put an x down here for my run. Now, I expect my answer here to be a little bit bigger than 5. Okay, just because of the way this works here, right? Where the numerator is a little bit smaller than the denominator. So I'm assuming this 5 here is going to be a little bit smaller than my x here. If I cross multiply, so 85 times x, and then I multiply 100 by 5, and that's easy, this is 500. And now 500 divided by 85, oops, 500 divided by 85 is going to be 5.88. Okay, or 5.9 approximately when I take that to the nearest tenth. And so there it is. It's just a little bit bigger than my rise. Okay, now this question is just saying, determine the slope of the following line segment. Okay, so I give you a line right here. So I want the slope of this line. Now, I'm pretty lazy here. What I'm going to do here is I'm going to grab a couple of points that I see here, that I see that the line goes through quite nicely. I'm going to grab what we call a lattice point. Okay, a lattice point. Now what I mean by that is, like for example, this point right here, let's say, that is not a lattice point. I don't know what the coordinates are of that. Okay, I can't tell easily from the graph what coordinate that is. But this point right here, I can tell you exactly what the coordinates are because I can read those off the graph here. And remember, I start horizontally first, so I go -3, and then I come down here, -1. So this has got the coordinates -3, -1. And then I pick another one here. And actually, I've only got 2 other points that I can see here that are actually nice lattice points. Okay, and so let's maybe grab this one over here. Okay, so we'll grab the furthest one over. This point right here is 3 over. Okay, so starting at the origin, I slide 3 over, and then I have to go 3 up to get to that point. So the point 3, 3. Here, -3, -1, 3, 3. Now, my slope, remember my slope formula is y2 minus y1 divided by x2 minus x1. So what I got to do is I got to decide, well, which point here is point 1, which point is point 2. And so let's just read it left to right. So let's make this one point 1, and this one over here will be point 2. So y2 is going to be this 3. y1 is going to be this -1, and the negatives are important. Okay, x2 is this 3 minus x1 is this -3, and again the negatives are important because up here in the numerator 3 minus -1 is going to be 3 plus 1 over 4. 3 minus -3 is going to be 3 plus 3, or 6. And then I should look at that and think, well, gee, those are both even. Those are both even, so I know that I can divide a 2 out of both of those, and it stays, the ratio stays the same. And so this becomes 2/3. So the slope here is 2/3. And actually, I didn't need to do this. I do this because there are a few people that don't trust themselves to count it outright, and they kind of default to this, and that's fine. There's no problem with that. But I could have just gone to this point right here, compared it to this one. From this point to this point here, my rise is 1, 2. I go up 2, and then from here I go 1, 2, 3. Now notice how I count that. Okay, when I put my pen here, I don't start counting here. Like when I count my rise, I don't go 1, 2, 3. My pen starts here, and then I count the steps. 1, 2. Rise of 2. Then I start here, and I don't start counting here. I start counting as I leave here. 1, 2, 3. and there's my run. So I could have just counted that out and gotten 2/3. Okay, this question says determine the slope of the line segment connecting this point to this point. And again, what I have to do is I have to make a choice. Which one of those is 0.1, which was 0.2? And you know what, let's not fight with it here. Let's just 1 and 2. So my slope is going to be y2 minus y1 over x2 minus x1. I mean, if it helps, write that out so that you could just have to fill things in. So y2 is going to be 12 minus y1 will be negative 1. So just comparing the y coordinates of the 2 points over x2 is 8 minus x1 is negative 5. Now, another little mistake that people make here quite frequently is they'll go y minus x over y minus x, okay? It's if you've got both points, okay, both coordinates of the same point in the numerator and in the denominator, you're doing it wrong, right? I need to compare the two y coordinates, I need to compare the two x coordinates. Now, 12 minus negative 1 is going to be 13. I'm going to add that 1. 8 minus negative 5 is also going to be 13 because it's going to be 8 plus 5 is going to be 13. And so 13 divided by 13, well, that's just 1. So that line has a slope of 1. So for every unit that it moves over horizontally 1, it's going to move up 1. Okay, so this problem here, we're adding a bit of a context to it. So a waiter makes $16 an hour. The following table shows the amount earned, okay, for a given amount of hours worked. Okay, so now so here's our chart here. So if he works 1 hour, he gets $16, 2 hours, $32, and it's so on. Okay, not a hard thing to kind of follow there. So what are the independent and dependent variables? Well, independent variable, that's the one that he basically has control over. And what he has control over here is the hours worked. The amount that you get paid depends on how much you work. Okay, it's not like you walk into work and the employer says, here's the amount of money that I'm going to give you. How much do you think you should work today? Nah. They tell you how much you are going to work, and then you're going to figure out how much you're going to get paid here. So the independent variable, okay, the independent variable is going to be the hours worked. And so as soon as I've identified that this is now my x coordinate. Okay? And that this becomes my y coordinate. So the dependent variable, that is going to equal the amount earned. Now, next question here is, what is the slope and what does it represent? Now, and when I ask what does it represent, I do not mean rise over run. Okay, I know that. What I mean is in the context, what does it represent? Now let's just take a quick look here. For me to come up with the slope, I need 2 points. Well, this is a group of x and y coordinates, So what I've given you here is, it looks like 6 points. So I just gotta pick 2 of them. So I don't know, let's pick this one and this one. So I've picked the points 2, 32 and 5, 80. So let's call this point 1, we'll call this point 2, because I need to have that label there. So now I'm going to keep that visible. So my slope, y2 minus y1 over x2 minus x1, is going to be, well, y2 is going to be 80 minus 32 over 5 minus 2. Okay, now 80 minus 32 is going to be 48. 5 minus 2 is going to be 3. And 48 divided by 3 is going to be 16. Like, you can think of it as 16 over 1 if you want, but 16. So then the question is, what does that slope of 16 over 1, what does that represent? Well, if you're not sure, the best way to compare this is to look at units. Notice that the units here in the y coordinate for the dependent variable, the units here are dollars. But the units here for the independent variable are hours. And so what this means here is this up here, the numerator, is going to be dollars per hour. So this is whoever this person is, okay? This is this person's wage. It's a wage of $16 per hour. That's what that represents. That's what I'm asking for. Please, when I ask you for what does the slope represent, don't tell me rise over run. I know that. I'm asking in the context, what information is that providing? Now, is the above a direct linear relation? Now, we haven't really mentioned that in any of these questions yet. But is it a direct linear relation? And the answer here is yes. Now, why or why not? That answer is actually a lot simpler than I typically get as a result here. This actually makes it's so easy to answer this. The reason it is because the graph, whoops, I don't know why I wanted to put an I there. Okay, let's just get rid of that bottom bit there. Yoink. Or the relation passes through the origin. That's all I need. For it to be a direct linear relation, I need it to be a straight line. Okay, I need it to be a straight line. So I need the slope to be constant, and that's fine. We've kind of, in this case, we kind of ran on the assumption that that was true, but it has to pass through the origin, or the point here is 0, 0, if you will. Now, if you're not entirely sure, well, how do I know that it goes through the origin? Then we can just explain that. If the waiter doesn't work, in other words, the hours of work is 0. If the waiter doesn't work, he does not get paid. Okay? That's it. No hours worked, no money earned. So the relation goes through the origin, and then as a result, we call that a direct linear relation.